What's up guys, Shawnthebro here, and today we're going over input buffers part 2. Now this is an exciting one because if we do this one, you can actually be able to press your inputs and you will be able to perform an action based on the inputs you pressed. And it'll even give you the name of the attack and things like that. So if I go over to my guy, I'm going to play a heart animation, kind of like as if I got hit in the kidneys effect when I press A, B, and C within 0.2 seconds of each other. Again, you'll be able to convert this into frames and things like that, so don't worry about that. But just for now, the point is, I'm going to press the buttons in the right order, and we should do an attack. There we go. Not an attack, but the kidney hit. That's the ABC combo right there. Now you can see if I take too long, like this, it's not within 0.2 seconds, the buffer clears, and I can't use my attack. If I do it quickly enough, I can use it, and I'm good to go. If we look at our output log, I've got some logging going on here. You can see if I press the buttons correctly, such as ABC, then I've added another input, and I'm using the command temp command, because that's the move I'm using. If I press either buttons in the wrong sequence, like they don't equal some sort of command that is stored in the game or in a database, or I press the buttons too slowly, then you can see it gives me a message. But if I press them quick enough, I'm using temp command. So this one I'm very excited about. This opens up a world of possibility for us. Being able to do this means we can have, as many commands as we want per fighter, things like that. And it also allows us to do things like hold inputs. Now, holding inputs like such as A and B or something like that, or on an Xbox controller, it would be A and B or A and X, whatever. Those aren't going to be done inherently. We are still going to have to take care of them. However, having this input buffer, and we have our timestamps and all, we can actually make that happen using this same basic logic. So we'll do that in another episode. This episode is going to be packed pretty full. Don't worry about that right now, but again, opens up a world of opportunity for us. So this one's going to be pretty heavy code side today. Probably the heaviest one we've had code side. So if you're not familiar with the series, you might want to catch up. We're 33 episodes in. You can see we've done quite a bit so far. I've got some more stages to show from Shadow Magnus. I've got some more content I want to show you in general. I added a few more characters that I haven't made playable yet. There's a lot going on. So if you want to catch up to the series and kind of get all the functionality that we've done, I'll go ahead and put the first episode here of this series so you can start from the beginning. Otherwise, if you're good to go, let's get started. So, okay, there's a few things we need to do today in the code. Quite a bit, actually. The majority of it's going to be in the code. There'll be a minor amount in the blueprint. So, if we get started, go to your fighter template character.h. So your default character that you're going to make the parent of all your other characters. Now, last time we made our f input info, and if you need to watch that episode, this is input buffers part 1. I should mention that because this is part 2, so it would make sense to show you the first one if you haven't seen it. So if you haven't seen the first one, there's the iCard. Okay, the f input info is basically the input that we pressed, the name of the input we pressed. So it's a string. So if we pressed up, it's going to print out up. If we pressed left shift, it's literally going to print out left shift. That's what the input name was. And the timestamp is when we pressed it, so we can do some additional logic with that. Now, the command is a new struct that I made for this episode. Use struct blueprint type so we can access it in blueprint. Generated body, and then in public, make fstring name, and then t-array of fstring inputs. So the name of the command, this thing I'm calling command, is essentially quarter circle punch. It's so this is like Hadouken or something like that. So the name would be Hadouken. And then the inputs are what you have to press to actually get that to occur. It should be noted, I'm not using access mappings here. So you will be able to use action mappings, but not access mappings yet. We will get into access mappings, don't worry, but it's can be a completely different beast because you kind of have to grab different values and use their access values. So right now, just focus on button inputs and key presses and things like that. So this system will work for that. I just wanted to point it out. We won't actually be doing quarter circle punch today. We'll just be doing different keys. Okay, so T-array of f-string inputs, because this is the name of the command, and this is all the inputs we're going to need. So in my case, it's A, B, and C are in this inputs array. All right. Now, that's all good to go, but there's a few more things we need to add before we can even get started with the actual logic. First of all, I've removed remove input from input buffer, that function. Now, you can feel free to do it in code. The thing is, for me, I looked it over and I went over the logic a little bit more and I thought about it, and I don't really think it's necessary to move it. I'll show you why in the blueprint, and I can actually go over it now if you'd like. But I'll just go ahead and open it so I can show you. I won't explain it. We'll do that later so it doesn't get too confusing. But it's the same logic. I've reversed the order. So where we were calling add to input buffer, I've gone ahead and put the removing logic before I put the adding logic. And this is the same logic from part 1 of the input buffers. I have not changed the logic at all, except I made it 0.2 seconds for the input buffer instead of 10 seconds because we no longer need to exaggerate it so you guys can understand what's going on. And again, I put add once the remove loop has completed. I'll explain all this in a little bit, and there's going to be more we're going to add, so don't worry about this right now. But I wanted to show you I have removed the function that I mentioned last time. So to avoid confusion, you don't need to remove input from input buffer if you copied that last time. I think I'm keeping mine in the blueprint because it seems, I thought it would be cleaner in code, but honestly, it doesn't really seem that it will make that much of a difference. Okay. I also removed the timer handle that I had that I wasn't using, and I left commented out for you guys just to show you. So again, just to keep you up to date. And I think I removed the time as well. I did not remove the time, so you can keep this. In fact, I'm gonna keep this because this is what we should be using instead of just the random 0.2 that we hard-coded. So just for the record, you should use this variable. That would be technically the correct programming practice. I'll make this 0.2 and use this from now on. Those are all the changes from the first part. I wanted to point them out so nobody got confused. Okay, now get ready for the stuff we gotta add. So I got two functions here that I've added. Oops, two functions here that I've added, and a temp command that I've added. So the first function, check input buffer for command. I made it blueprint callable. I make pretty much all my functions blueprint callable. The ones that I don't call toward the end of the project, I just remove the U function. I just like to have the option to be able to do it with all functions if I think I might use them. There's a lot of people who would not like if if they heard that. They'd be like, that's terrible. Honestly, it doesn't matter. If you remember to remove it at the end, it doesn't make any difference. If you think that having that exposed to blueprint is like the worst thing ever, then don't do it. We're not going to use it here today, but just wanted to point that out. Okay, so check input buffer for command. Now, the comment above basically says it, but what we're doing here, this function is what's going to check. It's going to parse through the input buffer. It's going to look through it, see if we can find a sequence in the input buffer that matches a sequence in a command that we have. Then start command is going to be what occurs if we are able to find the correct sequence in the input buffer to perform a command. Start command is going to take the name of the command and then perform that command based off of its name. Then lastly, temp command is f command temp command is an instance of this structure that we made up above. I called this f command. So this is just a temporary command where we're adding a name and the inputs. This is my ABC temp command. Okay, there's nothing else in here, I don't believe. I just want to double check. Well, there is a boolean called has used temp command. This will be used for the animation state machine, though. It's not really important for the actual logic right now. Feel free to add it now, though, so you don't have to add it later. I'll probably go over it again later. Don't worry about this boolean. I've mentioned this before. This is something I'm testing for another episode. So, ignore that. Okay, but yeah, if you want to add, this is this is the same way we're doing, like, was heavy X attack used, or was light attack used, and all this stuff. Just has used temp command. Literally just saying, have we used this attack? So this would be like, has used Hadouken, has used Shoryuken, things like that. Apologies for the butchering of the names there, but that's all. It's just going to check. So once we find the command in the input buffer, we'll set this to be true, and then we'll use it in the state machine. All right, I'm going to go up to the top, but I think we're good here. Now to get into the real fun. Let's go into the CPP file for our fighter template character. Scroll down to your constructor and go ahead and set your variables. It depends. Like, I should be setting my input buffer time here to 0.2. I won't bother with it right now, but just know that that's what you should be doing. And then here's what we're doing here. Okay, so I'm not going to go over inheritance in this episode, and I've kind of covered it from time to time, but we have this mutant character, right? He basically has everything that the fighter template character has, but we can override any one of his functions to change things specifically. I mean, essentially that's what's going on with his mesh even. The fact that he's showing up as the mutant character and using that mutant and a BP, but deriving from the fighter template character, means he's a child of that class. So in our constructors for our children, we'll have to go through and define all their commands. Now, I don't know if this is necessarily the best way to do this, not in terms of performance or anything, because it's not really a big deal there, but there might be an easier way where you just give it a command or give it certain inputs and let it loop. However, for me, this seems like this would probably be the most convenient way because you can kind of see them all laid out. And this, okay, so this temp command will be an array, by the way. So it's not right now, but let me explain. So this is just an F command, temp command. It's just an instance of command. However, you know, as you're playing your game, your fighters might seriously have like 10, 15 commands. I mean, maybe more, maybe less. And, well, I'm not going to make a variable for each of them. I'm just going to go ahead and make an array, a T array of F command, and then loop through that. That is too complex for this episode because we're already going to have a lot going on. So we're focusing on just getting one command done. We will go over arrays in the next episode. Don't worry about that, but the reason I pointed this out, this is how I'm setting it up. Feel free to set it up however you want. The most important things are you have the name of the temp command, which, again, Hadouken, whatever. Mine is literally called temp command. One, because it's in the fighter template character, and my actual commands will be in the mutant character when we get there in the game. And two, because, well, yeah, I don't have a specific move for it. I'm doing like a kidney punch right now. It's just proof of concept. Okay, and then to your inputs, temp command .inputs.add. Now, the first one you add will be the first one in the array. When you add them, they get added from first to last. So what I mean is, if I have nothing in my array, it's blank. I add A, it becomes A. Then I add B, it becomes AB. Then I add C, it becomes ABC. Just like that. So you can go ahead and add all your inputs. Make sure that your inputs are ones that can be pressed and they are the exact names of what the Unreal will pick up when you press that button. So if you're playing on keyboard like I am right now, you know, you could press like right shift, but if right shift isn't the name that pops up of the key from what we were doing in episode 1, you don't want to use that here. Make sure you use the name that's going to pop up in your screen. That's Audacity. Here you go. See how it's left mouse button, A, B, C, left command. So left CMD, you see that? Left shift, enter, all this stuff. You have to have these names. These are the actual names of the keys. So when you're doing this, make sure you're using that exactly. Okay. Anyway, I have a temp command. Its inputs are A, B, C, and I have has used temp command false. So if you're doing your array commands, go through and set every command so you know. Now, one last thing, then we'll get into it, but someone's probably going to call me out and be like, you should probably use a database for this or something like that. I'm going to hold off on doing that. You know, potentially, we won't do it at all until the end of the series, and it'll be an additional episode on how to do it, but we'll see. It depends. I don't feel like it's necessary for the tutorial. It depends on how many moves we actually get in here. But it might become necessary based on how many times we have to loop through it and stuff. So don't worry, I'm aware of that. I'm not just willy-nilly throwing this at people, but, you know, one step at a time. We're getting there. We're learning a lot little by little, right? So let's scroll down and make our new functions that we wrote in the header file. First of all, and it's pretty far down here, we need to make the check input buffer for command. It's a pretty daunting function. I'll explain it all. And then we need our start command, and you don't have to write this one right now. We'll do the check input buffer one first. Okay, check input buffer for command. Now, this function is used to find a sequence in our list of commands and see if we've pressed those buttons. If we have, then great. We want to start the command. We want to use that attack. It's that simple. But that's not as simple as it sounds. What we're basically asking is all the buttons that we pressed in our input buffer. Because sure, it's only 0.2 seconds, but if I'm matching buttons, I can really match a lot of buttons in 0.2 seconds. Especially if I'm on a keyboard, I can literally press about like 30 buttons, 30 keys in 0.2 seconds if I just mash my hand down. Well, you know, maybe we want to avoid it if there's other buttons that get pressed. Whatever. It's all up to personal preference. But my point is, you can press a lot of keys or a lot of buttons on your controller in 0.2 seconds if you're really trying. So, you know, you could have a pretty large input buffer. Now, with that, if you have a pretty large input buffer, you have to make sure that you loop through every button in there, just in case they have a sequence in there that you want to use. So we're going to have to loop through the inputs in our command, so A, B, and C, and we're going to have to loop through the inputs in our input buffer and make sure they match and in the same order, because finding them in an array is easy. Finding them in the same order in the array is much harder. Okay, so I'm going to explain this function in quite a bit of depth. It's a function I wrote. I didn't take it from anywhere. There might be a more efficient way to do this. If there is, please feel free to let me know. I'm always up for that. This is the first way I thought of doing it, and it seems pretty good. I have run some tests with it. Of course, you do have to do a nested for, but it's going to happen at some point in the game, so I'm not too worried about it. But anyone who's looking at this and like, it might be a little slow, feel free to let me know what you're thinking, and you know, we can talk about it if you want. But all right, the check input buffer for command. Let's stop stalling and do it. Okay, I'm going to explain this in quite a bit of depth because a lot of people watching the series, even if you've been following from the beginning, we haven't gotten into coding quite this complex. It's not too bad, but if you've never seen code before, this probably looks like a nightmare. So I'm not blaming anybody. What we're doing is we're having a counter. So this is the integer correct sequence counter equals 0. This counter is essentially how many inputs in our input buffer we've matched with the command. So I'm going to bring up Notepad because I think that will help quite a bit. This is my Maya plugin wizard. I don't want that. Let me bring up just Paint. I think Paint would be easier. We'll just draw it. It'll be ugly. Let me shrink this down a bit. Okay. All right. So say our input. Okay. I'm going to split this up. And this is going to be ugly, so give me a second to draw it. But I'm going to say input. So this is our input buffer. And this is our command. Remember, we're just focusing on one command right now, not like the array of the 15 commands that our character will have. Wow. Drawing in Paint is surprisingly complicated. Commands. Okay, so our commands, we just have one. We just have A, B, C. But for our inputs, we can have whatever we want. So I'm going to give you one where we screw it up. Let's do A, S, C. And we'll go through the logic, okay? So commands are what we're trying to match on the right side here. Inputs are what we put into our controller, onto our keyboard, whatever. Okay. We're going to loop through. This is a for loop. You've probably actually never seen this before if you're new to programming, because I don't think I've used a standard for loop in code before. I've used it in blueprints and I've used the for each loop, but this is a standard for loop. So what this is it takes in a value, integer command input 0. Now technically this would be I. I'm trying to make this as clear as possible. There's a lot going on here. So command input this is the index that we're on in the command array. Remember, we have a T array of inputs in our F command structure. All right? This is the index of this array, the commands array. So index 0 is A, index 1 is B, index 2 is C. That's all we're doing here. We're starting at index 0. We're saying as long as this index is less than the number of inputs in here, which there's 3 inputs in here, 0, 1, and 2. Well, 2 is less than temp command inputs num. Dot num is the full amount of the elements in the array, so 3. So as long as it's less than 3, we'll still do the logic. If it's 3 or greater, we're going to get an out of bounds exception, and the game will crash. So that's why we need to be sure we're doing if this value, if the index is less than the total number of indices in here. Then plus command input, this is saying add and go to the next index. So we go from 0 to 1, 1 to 2, and then we're good to go. Now same here, the input buffer, this is 0. That is not a 0. Let me erase that. That was terrible. I don't actually know how. Tools. There we go. Been a while since I've used Paint, so you have to forgive me for that. But this definitely deserves... oh my gosh, okay. Not the pencil. We're going to use the brush. 0, 1, and 2, right? So we also have to loop through our input buffer because, great, we have the commands we need in our command list, but we need to go through our input buffer and see what they've pressed and if it actually works. Because if we just find A, B, and C, well, if I have A, B, and C somewhere in my input buffer, but it's split up, we don't want to actually use that command. We have to make sure they're in the same sequence, just like this. So ASC would not fall under ABC, right? They just flat out don't match. I have an S instead of a B. So we need to go through the command inputs. Then we need to go through what's in our input buffer. Now, for our input buffer, I say for input equals 0, so we're starting at A. Input is less than the input buffer.num. Same deal here. We don't want to go out of bounds. So if the input buffer has 10 items in it, as long as this is 9 or less, we'll be good to go. But if once it hits 10, we end the loop. And then we're adding 1 every time. That's what plus plus means. So plus plus command input, plus plus input just means go to the next one. Once we're done this loop iteration, go to the next one. 0, 1, 2. Now, okay. What we're doing here, and I apologize, just laughing because me trying to explain this is giving me a headache. Okay. What we need to check, and sorry, I wish this could stay up and I could click on that, but what we need to check is we need to check and make sure that we don't, there's 3 conditions we need. So we need to make sure that we loop through and all the inputs in the command that we need to perform the command are in the input buffer. We need to make sure they're all in the same sequence, and we need to make sure that there's enough inputs in the sequence to actually be able to perform the command. So like I could have A and B in my input buffer, but that's not enough to perform the command. I need A, B, and C. So if they're not in the same sequence, if it's not the same inputs, or there's not enough inputs, we need to fail out of the loop and say, nope, don't use a command. We only use the command if we have A, B, and C in slot 0, 1, and 2. Or whatever, but consecutive in the array. Like this could be 3, 4, and 5. It would still work. We'll do some examples with it, so don't worry. But that's what we're trying to achieve here. So our correct sequence counter starts off at 0. Our input is our J value in the array for loop, if you're familiar with that. Otherwise, just remember, this is the index of our input buffer array. So we're starting at 0 for that. So let's go over the logic. We're starting at 0 in the input buffer. So we have A in the input buffer right now. I'm going to draw a line so we can cover this. Okay, so we have A right now in the input buffer. And we're adding, so this is 0. I'll put the index. Here's how this is going to work. I'm going to put the value and the index underneath of it. So we're at A, which is 0. And what we're grabbing is we're making sure the index that we're on in the input buffer plus the amount of correct inputs, the correct inputs in a sequence. So for correct sequence counter, Remember, this is what was 0. This is going to go up every time we get another input for a command correct. Doesn't matter what command, but as long as we're looking for any of the commands in here, we have to make sure that they're matching. So since A is the first command, or is the first input in this command, and A is the first input in our input buffer, then we go, okay, A is 0, and we're adding 0 because we haven't gotten any yet. So correct sequence counter is 0, so we're not changing anything, so we're still at index 0. And that's less than input buffer.num. Input buffer.num is just the input size. Remember, we want to make sure that we don't go out of bounds. This is just a safety check. We're going to be using the correct sequence counter to move along the command array. So we want to make sure that the input buffer.num is big enough to be able to hold the input, the index of the input buffer that we're on, plus the correct sequence counter. It'll make more sense as we end up showing you. But we've got A that's 0, and we're going to do a string compare here to see if they're actually the same letter or the same input. If input buffer, input plus correct sequence counter, that's why we did this if check right above it. Because if this failed, if this was greater than or equal to the input buffer.num, this would have crashed. We don't want to crash, so that's what this if check is for. So this is 0 plus 0 right now. So this is flat out 0. This is A. Dot input name. And remember, input name in the input buffer is just an F string that holds the name of the key or button we are pressing. In this case, the 0 index of our input buffer is A. So the input name is A. So there we go. A would be printed to the screen, correct? This is what we have in our input buffer. It's index 0. We're going to do a dot compare on the name to our temp command inputs, command input. You see that? So temp command is our ABC. All right, that's this right here. And then inputs are the array of inputs that we need to perform. And command input is this index right here, which starts off at 0 the first time we're going through the loop. For those that are completely new to for loops, the loops work like this. I already explained the conditions. You start with an index. While that index is less than a max amount, the max amount is the end of the array. And then you add one every time you finish. When you have two for loops inside of each other, like we do here, then this loop will run as many times. So the first loop runs, right? And we're on command input 0. Then we're going to go through this for loop entirely. So we're command input 0, but we'll go to input 0, 1, and 2 before we hit the input buffer amount. Then once this is done, we end this for loop here. We go back to this for loop, and then we will continue through this. So command input will then be incremented, which means 1 gets added to it, and we will end up at command input equals 1, and we'll start the cycle over. This for loop will restart, input will be 0, and we'll be searching from there. So the dot compare function in the F string that we have here for input name is comparing if 0 in the input buffer is equal to index 0 of the temp command. So here's this. This is what it looks like right now. On the command side, A is 0. On the input side, A is 0. Now, when you do compare, this compare function, I'll let you read the comment, but if it returns, you see that at the bottom, return 0 if equal, negative if less than, positive if greater than. So what that means, when you see I'm doing equals 0 here, this whole line is doing a check to see, let me highlight it, it's doing a check to see, is this index in the input buffer the same name, the same key, the same button as this index in the command buffer? If they are equal, which they are both A, then we're going to go into this loop. And this is where I print, or excuse me, we're going to go into this if statement right here. And this is where I print the log saying the player added another input to the command sequence. So the command sequence I'm calling is the specific set of commands that have been correct in a row, right? Meaning if I have A and then I put B, this will print out again. Then I print C, or then I push C, this will print out again. This is every time we pressed an input that could be used toward the current command we're going for. So since we pressed the correct button, we pressed A, and that matched something in the command, then we want to add to our correct sequence counter. We want to say, yes, we've gotten one correct for the command we're looking at. Let's go ahead and add to that counter and make sure that we can go ahead and go to the next input. Then we want to check and make sure if our correct sequence counter is equal to the temp command inputs.num. That means we would have gotten 3 in a row, because the temp command has 3 inputs in it, so inputs.num will return 3. If the correct sequence counter is 3, then we know that we've gotten 3 inputs in a row, and a command has 3 inputs in it, or however many inputs. That's why we're doing inputs.num instead of just hard coding 3. However many inputs this is. If this was a 10 input command and correct sequence counter was equal to 10, then we must have done the command correctly. So we go ahead and call start command. Now don't worry about that right now. We'll get into that after. This is the meat of today. So this is saying, yes, we've met the conditions. We are good to go. Go ahead and move on to using the command. Lastly, we want to break afterward. Break, I don't know if it has like a little, it doesn't have a little blurb. So break, what it does is it'll end this iteration of the for loop. The for loop will now finish itself. It won't look any farther for any other logic. It won't do anything. It's just going to break out of the for loop and go to the for loop above it. Break essentially just ends the for loop altogether. So we found our input. We don't want to continue searching, because if we continue searching at this point, then we could get a wrong input and start this over. We don't want to do that. So we can just break and save time and be good to go. Now, the command input is going to rise. Remember, we talked about this. So now command input is going to be 1. We're going to start this loop over. We're going to say, okay, command input is still less than inputs.num because it's 3, and we're only at 1 right now. So let's start the for loop over. So we're going to start at 0 again for the input buffer. And that's all well and good, but here's where a correct sequence counter really comes into play. So again, we have to make sure that our input plus correct sequence buffer is still less than input buffer.num because we don't want to crash. But if it is, then we can do something cool here. We're starting at 0 again, which is technically A. But input plus correct sequence counter knows to jump through the first input in our input buffer. See, we already know we got 1 correct, so there's no reason to try and look for A again. We're not looking for the same character anymore. So input plus the number of correct inputs for this command will get us the index we need. If input is 0, we've gotten 1 input correct. We need to look at index 2 of the input buffer to see if we've matched index 2 of the command buffer. Same logic here. But index 2 of the input buffer is S. Right. Technically, it's index 1. Programming is weird and starts at 0. So this is the first index. Index 2 is technically 1, and index 3 over here is technically 2 because they start at 0. That makes sense. So we have S, and in commands we have B at 1. So that's not good. We did not press the command we needed. So at which point we'll say, does index 1 of the input buffer compare to index 1 of the command buffer? It does not. S is not equal to B. These are not equal. So we go into the else statement here, where I log the player broke the command sequence. Basically just saying the player did not press the button that was expected to perform this command, so tough luck. Then we reset the counter, because we got to start all over when we want to perform a command again. Okay. Then, lastly, this else statement here relates to, you can always click on a bracket to match it with another bracket. So you can see this else statement relates to this if, which means if the input plus the correct sequence counter is less than the input buffer.num. If that's not true and it's greater than or equal to the input buffer.num, we also have to reset the counter because of, well, this reason. The player is not yet finished with the command sequence. Meaning, okay, say we only had 2 inputs and it was just A and S, or like we had a bunch in here even, however many inputs we were trying to match with the command, but we only had A and S and there was more in the command. Well, the input buffer is flat out not big enough to possibly perform the command that we're trying to perform. So since we're looping through them all every time anyway, we can go ahead and reset our correct sequence counter if the input buffer plus the correct sequence counter is less than the input buffer.num, or excuse me, is greater than or equal to the input buffer.num. There you go. So that's that. That's a failing example. And it might not have been the most clear. There's a lot going on here that you guys probably haven't seen before. So feel free to copy it and kind of digest it for a bit, if I could speak. And then let me know if you have any issues with it. First of all, now is a good time to bring up the Discord. You can join the Discord if you'd like. And then I can't put it in an iCard, but it is in the description. If you want to check it out and join, I'll be happy to help explain this. This is a lot going on, so I would not blame you. There's plenty who are able to help in case you had any issues. But don't worry, we're going over this again right now. We're going to go over a working example. Let's do a new one. We're not going to save this. Let's have inputs again. So, yeah, I probably shouldn't have cleared everything, but whatever. Input. This is the input buffer. This is the command buffer. M's are hard to draw on this, I will say. Command buffer. Okay. So now let's say in our input buffer we have A, B, and C. All right, and in our command, for the temp command, we're looking for A, B, and C. Okay, so this is at index 0, index 1, index 2. 0, 1, 2. Alrighty. So now our input buffer does match our command buffer. So in which case we want to use our command. I'm going to go through a little bit faster this time, but I think this one will solidify what's going on here. So we have our correct sequence counter at 0. We have our for loop to go through our command. On the first pass of this for loop, so we go into the for loop, we're looking for index 0 of the command, which is A. So we say, okay, let's go through our input buffer. We're looking for index 0, our input buffer, which is also A. We make sure that 0 plus 0 is less than the input buffer, and if it is, we compare the strings. So index 0 of input and index 0 of command are both A. We found a match. The player added another input to the command sequence, and then we upgrade the current sequence counter. So I'm going to put current sequence counter down here. It is now equal to 1. Okay. Right now it is 1. I'll box this in for you. Because we found A is a match. So, but the correct sequence counter is not equal to the number of inputs in the command. There's 3 inputs in the command. So this doesn't succeed. We break out, which is good. We go back into this for loop. We update this. Command input is now 1. So we're looking for the first index in command input. That is B. Okay? So then we go into our input and it starts over. So we're at input 0, which is A. Then we make sure that 0 plus 1, because its correct sequence counter is less than input buffer.num. If it is, we go into our compare and we see that input buffer 0 plus 1, which means index 1, which is B, compares to command index 1, which is B. If these are both B, if these are both the same, and they are, then great. Player add another input to the command sequence. So we go ahead and add to this current sequence counter. This becomes 2, and that's pretty ugly, but this is 2. I'm actually going to go ahead and erase this for you. No need for any confusion. Okay, sorry about that. So current sequence counter is 2. Great. So we added to the current sequence counter, and now we're gonna check and see if the current sequence counter is equal to the temp command inputs. It's not. Temp command inputs has 3 as its value, as its size, and we only have 2. So we're gonna break and we're gonna restart the loop. The command input is gonna increase. It's gonna increment. So now we're at 2 for command input. We start this other for loop over. So we start at 0 for the input buffer. We make sure that 0 plus 2 is less than input buffer.num. There's 3 in the input buffer, so we succeed. We go into the comparison. Input buffer 0 plus 2, index 2 is C in the input buffer. Does that compare to index 2 in the command buffer? It does. Input buffer index 2 is C. Command buffer input 2 is C. Index 2 is C, excuse me. They are both C. We succeed once again. Player added another input to the command sequence. We add to the command sequence. This is now 3. There we go. This is now correct sequence counter is now 3. If correct sequence counter is equal to temp command inputs, well, there's 3 in temp command inputs, and there's 3 values that we've gotten correctly. So now we can go ahead and start our command because we know we've properly input this command. Hopefully that makes sense. I'll probably do one more failing example, and I think we'll be good to go. But this is a tough thing to learn, so I think this is reasonable. Let me go ahead and switch this. I'm going to make correct sequence counter back to 0. And I will go ahead and change this up a bit. Okay. Let's go ahead and make one with let's do A, B. And I'll show you what happens if we don't have enough inputs yet, if we've only pressed 2. Because we're going to be going over the same logic either way, but this kind of leads you down the last path so we can see it one more time. Okay. One more time, guys. Correct sequence counter is 0. We come into the function. We loop through. We see command input starts at 0, which is A. Index 0 of command buffer is A. Okay? And we have to go through our input buffer. Index 0 of our input buffer is also A. And that's good to go. So we make sure that 0 plus 0 is less than the number of inputs in our input buffer, and it is because there's 2 in our input buffer. Then we compare. We make sure that 0 plus 0, that index in the input buffer, which is A, is equal to the command input value, which is 0, index in the command buffer array. So index 0 of the command buffer array is A. A is equal to A, so we're good to go. Player add another input to the command sequence. Add 1, and then we're not 1 is not equal to temp command inputs.num. So we break and we restart the loop. This updates to 1. Okay, this is 1 now. And we say, okay, command input 1, input 0. So we're looking now for command buffer index of 1, which is B. In our input, we're making sure that 0 plus 1 is less than input buffer.num, which it is, because there's 2 inputs still. So it is 1 less. So we check if input buffer 0 plus 1 compares to command buffer 1. So command buffer index 1 is B. Input buffer index 1 is B. Awesome. They match. Player add another input to the command sequence. Correct sequence counter updates to 2. And yeah, I really can't pull that off. I'm trying to make the 1 and 2 a 2. I think you guys understand by now, but just for good measure, make this a 2. Okay? And if correct sequence counter, so 2, is equal to the number of inputs in the command buffer, then we'll start the command, but it's not. Command buffer has 3 inputs in it. We only have 2 correct inputs. So we break and we restart. Now, command input, this is going to increment, remember. So this is going to be on this is technically going to be on 2, right? index 2 right here. So we're looking for C in the command buffer. Input buffer starts over, so we're at 0. We check if 0 plus 2 is less than the input buffer.num, but it is not. The input buffer has 2 elements in it. 2 is not less than 2. 2 is equal to 2. So this fails. We go into this where we reset the counter. The player is not yet finished with the command sequence. Okay? And otherwise, if we had an alternate ending where we had 3 inputs, but this one was a D instead of a C, and we have 2, we break. Remember, we're looking to compare if these are 2, or if these are correct. Command buffer index 2 is C, input buffer index 2 is D. So we get into here, 0 plus 2 is less than the input buffer, true. The input buffer now has 3 in it. Then we check if 0 plus 2, if the input name of that, well, the second index of the input buffer is D. If that is equal to the second index of the command buffer, which is C, we are good, but they're not. This is D and this is C. They're not equal, so we go into this else. The player broke the command sequence and we reset the command, or the correct sequence counter. This goes back to 0. Big fat 0. And there you go, guys. That's how this logic works. It is quite complicated. Trust me, it's very hard to explain, so if I said anything that didn't make a ton of sense, feel free to call me out on it or see if you can explain it better. But that's how the logic works. And I think by running through the examples, that should help a lot. I'm going to close this now because I think we are good to go here. But I think that was important to see. Otherwise, I could not talk my way through that, I don't think. So this is your check input buffer for command. Now, we need to call this command, or call this function. So every time add input to input buffer is called, I go ahead and check the input buffer for command. That's simple, because you don't want to be doing it on tick if possible, and you can just check every time a player uses an input that's going to get added to the input buffer, because if it's getting added to the input buffer, it's very possible it's related to a command, and it's the best place to do it. So there you go. Now, let's get into our start command function. Don't worry, it's very simple, but let's go over it. So remember, if we have the correct amount of sequences, or the correct sequence counter, and that amount is equal to the amount of indices, or the size of the command buffer, then we've succeeded. We have A, B, and C in our input buffer, and that's what was matching our command buffer. So we want to start that command. What we're going to do is we're going to make a function called start command, which I've already shown you, but I didn't go over this. It has an f-string command name. So in case you guys missed that, let me start command. It's void, but it has f-string command name. So the command name parameter is going to be the name of the command. Simple enough, right? But we're going to do this because we can actually compare them and things like that. All right. Cool. So once you wrote this function, go ahead and call start command within this if statement and use the temp command .name. Now what we're going to do in here probably won't make all that much sense as to why we're doing it like this until we're using an array in the next episode. But what we're doing is we're checking if the name that was passed in compares to the temp command .name. Remember, this is what equals equals 0 means when you see two f strings getting compared. It's checking to see if they are equal. So you're like, why are you doing that? You could just do this logic here. Well, if we have 15 commands, we want to make sure that we're using the right command here. So we can either do a switch statement or just string comparison, things like that, you know. But for this case, since we don't have an array, we only have one command, then I'm just comparing the name that gets passed into here to the temp command name to make sure that the name is getting passed properly. And then I'm outputting this to the log. The character is using the command %s, which is looking for, that's a string, but it's a character array. So, or I think it might be an std string, so don't quote me on that. But this is not an f string. I think you need to convert your f string to a way that this %s will be able to read it. Otherwise, you'll get like Chinese characters. So when you do %s, you have to make sure you take the command name. This is our f string, and dereference it. That's what this is. You put the little pointer, the little asterisk, and see, get pointer to the string. You can see it right there. So there you go. If you put this in, you'll be able to convert any F strings to %s's to use in logs. So that's how you can read what's actually in it. And I'll show you the log again once we get testing it. Then has used temp command is true, because we want to actually perform the action now. Alright guys, so that was pretty much it. Don't worry, I do want to go over the animation blueprint, and I do want to show you the character blueprint, just so you can see. For the character blueprint, I told you I would go over this, but I've changed the add to input buffer. I've changed this input action to add to input buffer P1 and add to input buffer P2. I still haven't added P2 in the logic yet, but just to show you so no one is confused, they now look like this. They're both any key right now, but remember, we want to actually make sure if we're on one input device like a keyboard, player 1's inputs are on player 2's side, and vice versa, right? If player 1 is pressing player 2's inputs, they should be going to player 2's input buffer, because otherwise it doesn't make any sense for player 1 to perform that action. So we'll be fixing that up, but I just want to show you, I did separate it into P1 and P2, so you might want to rename one and then make a new one. They can both be any key for now. Now, if you watched the first episode, and I explained it earlier, put the remove before the add. So remove the elements in the input buffer that are ready to be removed because the timer has run out before we add new ones. If you don't do that, you'll get some weird logic with the code we just wrote. You'll need to actually make sure that the first input that you're putting into the input buffer is for the command. Otherwise, you'll have ones left over because you'll be adding new ones and checking to see if they're valid in the command buffer while you still have the old ones in, which we don't want. We want to make sure all the old ones are removed first, and then we go ahead and add the new ones, and then check to see if the input buffer matches any of the command buffers. And then I'm still printing the same way, so feel free to put this at the end still, just after the add. There's more things I'm doing up here that aren't related to today's episode, so if I zoomed out just like now and you saw that, don't worry, just ignore it for now. These are things I'll be explaining later. Wanted to make them aware to you. Try not to do anything without you guys knowing about it. Lastly, in the animation blueprint, you guys have probably already done this a few times, especially if you're watching this video in the series, so don't worry about this part too much. It'll be nice and easy. But remember, we have our new variable called hasUseTempCommand that we set to true in the start command. So we want to make sure in our reset variables, we reset hasUseTempCommand back to false. And remember, we call reset variables when anything happens, basically. We call reset variables if we start attacking, end attack, and jump, any of that stuff. Okay? So once we are done our Hadouken or whatever move it is, then we can go ahead and reset that, and then the player has to input the command again before they can use the attack. Simple enough. In the state machine, I went ahead and made a new machine. I also called it, or excuse me, not a new machine, a new state, and I also called it temp command because, well, that's the best name for it for right now. So right click, add state, call it temp command. Our transition rule is we grab our mutant character reference that we have down here. We grab our hasUseTempCommand, and remember to make sure to build once you're done with all the coding. Once you succeed there, go ahead and go here and hit compile. And once you see this variable, hasUseTempCommand, go ahead and put that as the idle to temp command rule. Okay. And set your start transition event to start attack transition. I know I'm doing like a kidney hit thing, so it's not really an attack in my case, but it literally does not matter what's in here. Once you've gotten to this point, we're not worrying about the commands anymore. We've already done the command to call this animation, so put in a super move, put in a projectile, put in whatever you want here. Doesn't matter. But if you want to reset your variable afterwards, make sure you have a transition event here, like start attack transition for me, which calls reset variables. And attack transition also calls reset variables, so you'll notice that I do that on the return and attack transition. This is temp command to idle. Now, temp command to idle, as most states in our game. Doesn't have actually any rules in it. What it does is it checks if automatic rule based on sequence player end state, which I've said enough times so I don't really have to go over. But basically, if the animation is finished and it doesn't have a better state to go to, it will use this transition rule. Temp command can only go to idle, so at this point it doesn't have a better transition rule. So once the animation has finished playing the kidney hit, we're going to return back to idle. And yeah, lastly, I already showed it, but make sure you plug in an animation, otherwise you'll just T-pose. And you should be good to go. Whew, that is a tough one. So let's see it in action real quick for our hard work. Go on Pedro's nice stage, check it out. Alright, so player 2 won't be able to do this yet, because this is all for just player 1 at the moment. If you go ahead and press your inputs, you can see I can press ABS. So remember we did ASB, right? So we did ASB. You can see ASB is not working as an input, as we predicted. We did ABD, which you can see ABD is not working. But we did ABC, and ABC worked. You can see when I put in ABC within 0.2 seconds, it works. So there you go, guys. I can do as much as I want as long as I don't screw up my inputs, and I'll be good to go. And yeah, that's it. I mean, that is it. We are finally able to use input buffers in our game. Will be, I wanted to make this 3 episodes. It might end up actually turning into 4 because I want to cover axis mappings and doing I don't really have a joystick I want to use at the moment, but we should cover it for quarter circle and things like that. So that one might come a little bit after, but we will be doing an episode on that, so don't worry. If you're looking at this video somewhere in the future, just look around for it. It would be called Input Buffers Part 3 or Part 4, depending. And I'll probably have something like axis mappings in the thumbnail. That way you guys are aware of what we're going to be doing in that episode. But that should be good, and we'll be covering... So you see how we're just printing a string right now? That's fine. But I want to make it nicer. And in practice mode in a lot of fighting games where they actually display a stack of inputs. So if I press A, it's the A. Well, we have to kind of make those images, so I won't, do the whole keyboard, but I'll show you how to do a stack with inputs. So when you decide what your final controls are or anything like that, you can go ahead and print them out. We can do light, medium, heavy attacks and up, down, left, right, whatever, those kind of things. So we'll do an input buffer episode on that because that's related. Lastly, regarding input buffers even, we'll do another one where player 2 can also do it. That one won't be as long. We might actually shove that into one of the other input buffer episodes. But I wanted to tell you guys, because we got a lot going on. Input buffers take a lot of work, and there's a lot of content to cover with them. So, yeah. Alright, I think that's it for the input buffers. My last update, I guess, in general for the fighting game series is we will be doing grapples relatively soon and things like that. We'll be covering kind of how to hold 2 inputs to perform an action, such as a throw or a grapple or whatever move you want to do using our input buffer, but it'll be its own section. And we're going to be finishing up Ultimates Part 2 relatively soon as well. So just some general updates for you. Yeah, that's all I got there. Lastly, guys, and I keep saying lastly, so don't trust me if I say lastly, but thank you so much for the people who are supporting me on Patreon. I mean, I never really thought to bring that up because, I didn't want to bring it up, but I didn't want to feel like anybody was outcasted. They were an outcast for not supporting Patreon, but a good friend of mine who joined the Discord, I don't know if you want to use your name or whatever, I've never really put this out there before, but he went ahead and supported me on the $10 tier on Patreon, which is incredible. So thank you so much for the support there, friend. And, hopefully I continue to make content that you enjoy and that you guys can learn from. So, alright guys, anyway, that's genuinely it for me. So if this video helps you, please subscribe. It took a tremendous amount of effort and brain power to try and explain that. Or, let alone make it, but explain it was much harder because it's hard for me to kind of get my thoughts together in a way that's easy enough to explain it. It is not a simple concept. I mentioned it earlier, so I'll give you the short version. But if you want to join the Discord, feel free to go in the description. There's a link you can click. We'll be able to help you with anything that went wrong in this episode or just in general. Yeah. And then lastly, if you want to come support us on Twitch, Shawnthebro... Nope, that's not it. You can tell I'm tired from talking this much. Twitch.tv/ShawnTheBro27. You can come check us out. We do Dark Souls games on Wednesday, and we do Resident Evil games on Friday. So we've been having a lot of fun with that. And yeah, that's it. I won't eat up any more of your time. So thank you so much, guys, so much for watching this episode. I'm Shawnthebro, and I'll see you in the next one. Goodbye, my friends.